You may or may not have voted on what we are going to do in this class, but there was a forum, and there was 4 responses, which isn't bad considering the number of people who come into this class, because I think we peaked at maybe like 6. And so, there's a bunch of different options. Actually, did the 2 of you vote? Awesome. So there's a wide variety of respondents in terms of like what was the most popular thing. But actually, the one thing that everybody was really into was NPC movement using AI NavMesh, which is what today's class is going to be about. But future classes, setting up a third-person player character with your own custom third-person character is popular, as was basic modeling and texturing in Blender. And also, I think that creating a game master was also one of the more popular ones. So, but I'm going to leave this up in case we get any other respondents. But so today, what I want you to do is just to create a empty 3D project. So when you're in the Unity Hub, you can just do new project and choose universal 3D template. And it'll just be an empty 3D. So now, of course, it's going to take you a second for that to build and be ready. But you might ask yourself, well, could we do AI navigation in a 2D game, like whether it's side scroller or top down or something like that? And the answer is not with the built-in Unity navigation system. And it's because this navigation system that's built into Unity that you can use right off the shelf specifically works in the XZ plane. It expects that you're in a 3D world where you got the XZ plane is where your navigation takes place, and it will account for like elevation differences or multi-levels and stuff. You could hack things to make this work in 2D, but actually there's packages that you can get from the Unity Asset Store for example, like A-star pathfinding that will work for those kind of cases. So it's possible to do that if you wanted to have this kind of navigation in 2D game. And it's not terribly hard to write your own code for simple 2D navigation. Like if you have like, you got a 2D side scroller and you have a flying enemy that you want to kind of like be moving around and then path towards the player. But what we're going to do is we're going to be looking at, being in a 3D world. And so like, let's see if I have my, I have my 3D world here. So the whole idea is that like, all right, we're going to use the built-in system and see how far we can take it. And we're going to be specific to, a 3D game. Although you can always have a camera that is set to be the isometric perspective, so your camera here, like if I throw, like a sphere or cube in the scene in a place where the camera can see it, you've got, and better yet, I'm going to create a cube that I'm going to use for ground. And I'll make this like, like 50 by 50 by like 0.5. So, if I were to change my camera so that it's orthographic, let's see, you can get some really interesting kind of 2D feeling gameplay out of an isometric camera. And you can even create, for example, 2D characters and 2D objects that are in a 3D world that give an interesting kind of feeling, like if you've ever played the game Don't Starve, or like, for example, Dave the Diver is a 2D game that has 3D elements and a 3D space. You can still get a really interesting look. But one of the things that we want to do is, let's see. So y'all are still waiting for your games to build. One of the things that I'm going to recommend you go out and, one of the things that will help us see what we're doing a little better is after you get set up, I'm going to have you look in the Unity Asset Store for these Gridbox prototype materials, which are free. And there's a variety of different materials. But what's nice about them is that they all have this kind of like gridded shape that allows you to have different colored materials to put on things to differentiate them. But it also, this grid shape helps you to be able to tell relative size, distance, and when things are moving around. I mean, you could work with, just, gray assets in the Unity editor, but like, having these kind of prototype materials makes it much easier to see what you're actually doing. So yeah, if you like, I mean, you should be able to just search for in the Unity Asset Store for Gridbox, and you'll find these prototype materials. So while you're waiting, you can go ahead and log into the Asset Store, and you can go ahead and find the Gridbox materials, and you can add them to your assets. They're free and they're super useful. And while we're waiting, what I'm going to do is, let's see, actually, I'm going to save this scene as my test scene, but I'm going to give you a little bit of a preview of what some of the things we're going to do. So for example, we can start out, I have this, I've created myself some ground, which is just 50 by 50 piece of ground, and I put the Gridbox green material on it. And I've got a capsule that I'm using as my theoretical NPC, the one that's going to do the movement. And the other thing that we'll have to do is we'll want to give it a target, something that it is trying to move towards, and we'll create just a sphere for that. But those grid materials will help us to be able to see these things clearly and to see the movement and understand relative speed as we're dabbling with these things. So yeah, once you get in and you get the, you can get the grid material or Gridbox material. Of course, from the asset store, you can click Add to My Assets. I'm not logged in, so it's probably, it would know otherwise that I already have that in my library. But you can also use the link from the website to open it in the package manager by clicking Open in Unity. So when you do, Unity will automatically open the package manager to that specific asset. So you'll see I've got, actually, I did a pretty poor job of that. But if I were to look for Gridbox. So what you'll see is Gridbox prototype materials. So I already have it in my project. But what you can do is you will click Import, and it'll give you a window where you see that you can just go ahead and bring all of those things in. You'll note that there's actually materials and textures for URP, HDRP, standard. You don't technically need them, but they're not really heavyweight, so it doesn't matter if you just go ahead and bring everything into the scene. All right, so as mentioned, once you have the materials, they'll wind up here in your assets in your project, and it'll create a folder called Gridbox Prototype Materials. You'll have a folder for materials and a folder for textures. You don't need to worry about the textures because they've already provided you with materials. You'll want the URP materials. And if I have this viewed as a list, but if I scroll it over here, I can actually see kind of a preview of the different colors. Maybe that's it. Yes, open that. There you go. You know what I probably did is I probably cleaned. I have a tendency to clean things up and kind of bring that folder up to, so I probably took that folder, dragged it up to assets, and then deleted the extra folder. So I'm kind of a meticulous organizer and have a tendency to do that. So sorry for the confusion there. But yeah, so now that you have the materials down, you'll find them in the URP folder, the ones that you're looking for. And so what you want to do is try to create a scene like I have here, where you have a ground that's roughly 50 by 50, 50x and 50z, with like maybe one, height in y. And then, you can pick any material that you like and drop it on there. Now, chances are, because it's scaled up to 50 by 50, whatever material you drop on there is probably going to initially look kind of weird. Like if let's see, the tiling is 1 by 1, yours might look kind of stretched out. So you may need to change the tiling to make it like the tiling 50 by 50. So drop a material on your ground and just see if it looks reasonable. Like a way to test that, because since you've stretched, the cube that was 1 by 1 and made it like 50 by 50, you may need to change the tiling of the material so that it's roughly 1 by 1. So if I, for example, if I put a regular cube out there that's just 1 by 1 by 1, I should be able to, essentially, if I reset it to 0, and then I've got snapping turned on, but you can see that my 1 by 1 by 1 cube fits precisely in this square. And it's because I have my material set to a tiling, let's see. Here, yeah, it has a tiling of 50 by 50. And that's because if it was 1 by 1, you would only need the tiling set to 1 by 1. Now, the other thing you'll notice that I have snapping turned on and at a 0.5, which will probably also help us just to keep things kind of on grid. So now you should have a ground that is scaled correctly. How are you doing, Johannes? Okay, excellent. So now that we have a wide open space to work with, you're going to want to create a 3D object capsule, and you're going to name that your NPC or NPC AI. And when you bring it out here, a scale, leaving it the scale of 1 by 1 by 1 makes it, actually roughly the size of a humanoid. And then I would, what I recommend is pick a different color that stands out well and drop that material on your NPC. Something that, will stick out from the green background or whatever color you decided to choose. And so, yeah, if it wound up at some weird place, you can always reset the transform and then pull it up a little bit until it's just right above the ground. If you pull it up to like 1.5, it'll be pretty much where you can, look down the side. See, if I have ground selected, you can see this thing is sitting right on top of the ground, which is pretty much where we want it. So if you don't have this widget here, that's this thing here in this toolbar. So then the last thing we want to create is a target, something that we're going to use as our destination. So what I've done is I've created a sphere by doing 3D object sphere. I named it destination, and I put a red color on it. Just another way to better differentiate. So I'm actually going to switch over to my test scene. Let's see. And so I've got to catch up to y'all a bit. Let's see if I put this on. Did I get that 50 by 50? Yeah. Let's see. There we go. I've got my color on it, my ground. I've got my sphere. Put a red color on it. And that's my destination. And then I'm also destinatio. It's Italian. So then I also need to create my capsule, which is going to be my NPC, and I put color on it. So now we're at roughly the same place. Great. And then I think I'm going to take my capsule and put it at kind of 0, 0, 0. Like I realized, yeah, oh crap. I just want this to be 0, 0, 0. Number lock. Now, 0, 0. There we go. Move that down a little bit. All right. Okay, so one of the first things we want to do. So right now, my the grid that I turned on here is kind of like confusing with the grid material. So I'm actually going to remove that. Let's see, bring this up here. The way that I think it's because distracted by perfection. Damn it. So one of the things that we want to do is actually, first thing we're going to do is we're going to turn on this. You'll note that there's a toolbar, or there's a button down at the bottom of this toolbar that has it's the toolbar of toolbars, and it actually says AI navigation. If you turn it on, and you'll see this window here that shows, show nav mesh, and we have it checked. Because the first thing we're going to do is we are going to apply nav mesh to our ground. So if we select the ground, we go to add component, and if we just type NAV, before we do anything else, like note that we have a number of interesting components that are related to AI navigation. We have nav mesh agent, nav mesh obstacle, nav mesh link, nav mesh modifier, and modifier volume, and nav mesh surface. And you can see that those are all kind of built into Unity because they've had these fancy icons. So select nav mesh surface. So this will add a component to the ground that is going to apply nav mesh surface, but you don't see anything different. Even with this AI navigation turned on and with the gizmos turned on, nothing's changed here. And that's because in order to create nav mesh, you have to bake nav mesh. So it doesn't just come with the component itself. Every time you make a change or do something that's going to affect the nav mesh, whether it's actually changing the level geometry or changing the stats, you need to click this button that says bake here in the component nav mesh surface. And when you do, you'll see that you get a light blue tint here. And so that's the actual nav mesh. So give that a try. Do you see the kind of light blue nav mesh on top of your green texture? There you go. So you have to have the gizmos visibility turned on in order to see it. So you'll see that if I toggle the gizmo here, that the nav mesh debug view is a gizmo and shows up just like that. You'll also see something that's interesting that we'll address later, which is like the nav mesh is everywhere on the ground except for right underneath our intended NPC. It actually automatically cuts out nav mesh from around static objects in the scene like this. And it may even be that, let's see, I guess, where's my destination at? My destination was actually underground, and so it didn't do that. But I wonder if I rebake this again. It does look like it kind of it made some pretty wonky nav mesh around this as well. But the point is, all right. So we're gonna fix that in just a second. But let's talk about the two main components of AI navigation. So you got nav mesh now. You got nav mesh on the surface that you want the NPC to walk on. The next thing you need to do is you need to make the NPC capable of moving on the nav mesh. And we call we call NPCs moving on NavMesh agents. So if you select your NPC game object, go to add component, chances are you maybe still have NAV here, and the very first thing is NavMesh agent. So if you add that component, now you've got a game object that's capable of moving on NavMesh, and you have all these tunable parameters, and we'll get into what these actually do shortly. But one thing we're going to do right away, because it can potentially mess with our NavMesh, is we're also going to add one other component. So we can collapse our NavMesh agent component so we can see the add component button. And we're going to put on a NavMesh modifier component. So when we do that, the very first thing here is the mode for the NavMesh modifier. And it says it defaults to add or modify object. But if we click on that, we'll see the other option for this property is remove object. And what that does is that component removes the object from being considered for NavMesh baking. So now if we go back to our ground and we click bake, now that missing NavMesh underneath our NPC disappears. Now the bake is ignoring that. We probably also want to do that for our destination. You can see, our destination here has kind of created some kind of awkward, wonky NavMesh here. So if we do that for our destination as well, we do add component, NavMesh modifier, switch it to remove. Now go back to our ground and bake the NavMesh, that wonkiness goes away. So now we have the basics that we need, but we actually need to create a script that tells our NPC to navigate to our destination using the NavMesh. And this is remarkably easy to do. It's really only a couple lines of code. So let's see. I've already created one myself, which I call move to point. So create your own script called move to point by going to create model behavior script and name it move to point, capital M, capital T, capital P, all one word. And so then in order to open it up in Visual Studio, you'll double click it. And in order for this script to do what it needs to do, it needs two things. It's going to need the transform of the destination. It needs the destination and it needs to get the position of it. And it can do that by getting the transform of the destination. You'll also need to get the NavMesh agent component, which is going to be on the same game object, because we're going to put this script onto our NPC. And that's why we can make it private. So if you like, I can make it easy on you too, is I can just post this code into our Discord. Or you can write it yourself, because you can see it's really not much, considering that you get the start and the update functions already. So you'll have public transform destination, private NavMesh agent. And that when it starts up, you'll assign the variable agent the NavMesh agent component by using get component. So you can either copy that from the Discord, or you can, using IntelliSense, as you start typing, it's going to start filling in some of this stuff for you, and it will make it pretty easy. But I'll give you a moment to catch up on that. Absolutely. What's a NavMesh? Yeah. All right, so there's different ways to allow an NPC in a game to navigate. And there's lots of different methods for doing something. So a navigation mesh, nav mesh for short, is when you actually, what we're doing here is we're actually creating a mesh, which is like literally a 3D geometry. You know, a mesh could be like the mesh, you know, this sphere, you know, you have a mesh renderer, and that's how you, the mesh is the sphere. It's the triangles that make up that shape. And so, you know, the ground itself has a mesh renderer. It has, you know, because it's, you know, a cube, you know, this is one quad, which is actually two triangles. So what we do is we create, NavMesh procedurally creates this 3D geometry, and it's going to say, okay, I can find out where the agent is on this piece of geometry, and I can find any point on this geometry using math. So, I mean, you could have, you know, there's different ways to have things navigate. You can literally have things navigate from point to point. Like, for example, last night in the intro class, we wrote a script that had an object move from like one position in 3D space to another position by just translating between those 2 points. So in a way, you can tell something just to move from point to point. You could have a bunch of those, and you can tell it to, you know, to move to the closest point of where you want it to go. But in this case, what's nice about a navigation mesh is that you can have that navigation mesh computed over as much geometry as you want. And so you can create, I can create a giant level that has rolling hills and all kind and changes in elevation. And when I ask it and I throw a nav mesh surface component onto one of those things, it will map out nav mesh that will essentially kind of be like a blanket that you throw down over all the geometry that attaches to it. We'll see a little bit of this a little later. Does that help? The more you work with it, the more you'll start to understand like how it works. But there's other methods of navigation as well. But navigation mesh is super flexible in this regard. So what we're going to do, to go back to our move to point script, is that so you should get your nav mesh agent from you know, it's going to be on the same script, and then when we get to the update function, we're going to call agent.setDestination and say, okay, the destination is the position of our destination using the transform. So now if I jump back to Unity and I take and I put that move to point on my MPC, so for example, if I take the move to point script, I just drop it onto my MPC, you can see the public field for destination is here. It's something I can assign in the editor. So I can just drag the destination represented by the sphere and drop it in there. So what's nice about that is instead of saying that the destination is a specific XYZ coordinate, now wherever this destination game object is, no matter where I move it around, the script will always be referring to it as the place that the NPC wants to go. And because we're telling it in the update function, which is called every frame, 30 frames per second or more, always move towards that destination. Whether the destination is static or if the destination is moving around, it will always use the navigation mesh to path to it. And we can actually see this, and it's actually pretty cool. So for example, just to validate that it's working, like let's make sure that our destination is somewhere, the destination needs to be somewhere on the nav mesh. And you know, you generally want it to be like relatively close to the nav mesh. Even if it's a little bit above it, it's not a big deal. It's fairly tolerant. And so, you know, we want to have our camera, you know, it really doesn't matter where our camera is because like, you know, we don't even need to look at the game screen. In fact, if you have your game screen up here, you can drag it down here so that we see the game screen and the scene view at the same time. Because, you know, we can see, while the game's running, we'll see the changes in both of these. What's nice about the scene view is it's not constrained by the position of the camera. Like we could actually have it move around while this thing's running. So now you should be in the position where you can actually press play. And so now you can see that your capsule, your NPC, should move towards your destination. And you'll notice that in both of these windows. Now, leave it running, click on the destination in the hierarchy or in the scene view and move it in the scene view, and you'll see that the NPC will continue to follow it, even though you're changing the destination while the game is running. So it's continuously updating to follow this thing. You can even just see, oh, how tolerant is it of like the destination being above the nav mesh? Can I, once I've lifted it up a certain distance, it's kind of become disconnected from the nav mesh. So you can say, okay, well, but once I get it relatively close, that's probably like, how many units is that? It's 5 units high, and it still detects it. And so you see that there's a bit of, you don't have to be ultra precise with your destination being sitting right on top of the nav mesh. It's fairly tolerant of it being above it. So now you've created an NPC that will navigate to, a destination. Now you can imagine that because we know that this destination can be static or dynamic, the destination could be the player. So you could essentially have a first person or third person player that can run around in this environment, and all you have to do is drop that player onto the NPC's destination field, and it'll take the transform of the player, and the NPC will path towards the player. So now you've got an NPC who will chase the player. And it only took, like 2 lines of code, really? Getting the NavMesh agent that's on that same game object as the script and telling it set destination and doing it in update. Now, if we put the set destination in start, it would start out and it would go towards it. But because it's not continuously updating, if it moved, then it would continue going to the original destination. All right, any questions?
So what we did before, when we selected remove object,
So what happens is that by default, let's create a 3D cube, and let's just call it wall. And so if I kind of reset it so that it's in the center back on the grid, pull it up a little bit. Now let's make it kind of, just a little bit easier to see by stretching it. Doesn't have to be precise, and you kind of want it sitting on the ground. But let's say we've got this wall. Let's put it actually, in between the NPC and the NPC's destination. Now, right now, if we run the game without baking the nav mesh, the NPC is going to ignore that and go right through it, which is interesting because the wall actually has collision. So the navigation is actually overriding the natural physics system that would actually prevent that from happening. But now, without even doing anything to this wall, if we select the ground and then bake it again, you'll see that it automatically cuts the wall out of the nav mesh. It even throws some nav mesh onto the top, which we can talk about that later. But the thing is that now if we run it, having rebaked the nav mesh, you can see that now it paths around this wall to get to its destination. So actually, it if you've got a object, and I'm not even sure you need to have collision on the object. Like if I turn off this box collider and bake, I think it does the same thing. So yeah, nothing changes. So it's looking at the mesh and not even the collision on the wall. It almost becomes irrelevant. And you can actually adjust, you can see how much space it gives there. You can adjust the parameters of the NavMesh surface in order to give more or less space here. And you can adjust the parameters on the NavMesh agent, the MPC, about how fast it'll move and how tightly it'll turn, etc. So for example, if I open this NavMesh agent, and I'm going to go ahead and move this kind of further away. So now if you look, under the steering part, there's something that says speed. So if I reduce that speed, I'm slowing it down to a crawl. Or I can speed it up and make it go quite fast. It'll even go so fast that it overshoots. Yeah, exactly. And then it also has this notion of stopping distance, which is like, how close do I need to be to something before I say I'm there? You'll also note that under agents, you can show path polygons, and you might note that if you've got your MPC selected, when you're running, you'll see that there's this line, this pink line. It's kind of faint, but it's showing you the path that it intends to take. So there's some additional debug information. You also see that light blue arrow that helps show the direction that it's pointing in. So there's a lot of ways to fine tune, like the speed, angular velocity here. Angular speed is how quickly it'll rotate. Acceleration, of course, is how quickly it'll come up to its maximum speed. Stopping distance is like when it knows it's close enough to stop moving. Obstacle avoidance is how far it'll go steer around things. So there's actually, it's really quick and easy to get an agent moving on NavMesh, but getting the movement just right, so you don't do things like overshoot your destination, can actually take a lot of fine tuning. So if you're going to make, like, for example, I recently was working on my own tower defense game, and getting like the creeps to hug the walls and to stay kind of in the center of the maze and stuff like that can take quite a lot of fine tuning. And sometimes it's a balance between getting them to move at the speed you want, but to path in the way that you want them to do without overshooting things. So, what I want you to do now is I want you to create a maze. So I want you to, playing around with this idea that you can set up your own walls as blockers. I want you to create a maze for your NPC and see, like, well, just how complicated can I make this? Like, how many twists and turns is there? Like, how narrow can I make things? Like, do something straightforward at first, but then push the limits of, what comes easily and cleanly. So for example, I've got this maze with just a couple of walls. And you can see, actually considering it's something that's just an out-of-the-box solution, it's pretty robust that it can go this far and navigate that well around these corners. But while you're at it, also note that you can play around with the speed of the agent, the angular velocity of the agent, the acceleration. So we're going to take a bit of time to just kind of play around with this before we move on to things like multiple levels and elevation and such. And if you open up the NavMesh agent component, that one there. So now you can change speed. You see that how your mouse has got the arrows there? You can actually click and drag left and right. There you go. But you see, if you give it too much speed, the velocity, the momentum will carry it to the edge and banging up against things. So, I mean, there is, depending on your application, you may actually need to write additional code to do things like know that you're approaching a tight turn and have it reduce its speed. That's not something that it necessarily does very well, fresh out of the box. So there's a lot of additional code you can write to do things like detect that you're approaching a wall and slow down or stuff like that.
Right now, I
Yeah, yeah, it's kind of. But the other thing that you can tweak is the angular speed, which is how quickly it rotates. So if you have a very slow angular speed, if you're going really fast with a slow angle speed and you're trying to make a 90-degree turn, you'll be going so fast and your turning can't keep up with it, right? So if you're going faster and you want to make a tight turn, you'll need a higher angular speed to be able to turn fast enough to maintain that. But there is a bit of a give and take there. This is all like, physics calculations, essentially.
Just tried
Yeah.
making him a bit taller
Uh-huh.
and just to see that
If he
it
would
just
pass through
passes right through here.
it does,
I guess
exactly.
it just respects this.
It does, and it ignores all collision too. And yeah, you can see that, like, there's a certain height which you can adjust. You can actually adjust on the if you go to your ground and you go to your nav mesh surface, there's actually there's actually a entirely different tab. So let's see. I'm going to close this tab. You see that you get kind of a visualization here of something called, like, you got the step height, like how high will it still step up onto something, or what is the slope, the maximum slope that it'll navigate on, and how high do I expect my agent is. And those are things that you can set up presets for, and you can change and edit. One of the things that's available to you to adjust this, I think there's a quick way to get to it, but actually you can go to Window, I think it's AI Navigation. And so what this does is it opens up this panel, the navigation panel, and you can adjust these things. And you can see by default it names the one that is using humanoid. But you could have a different kind of different nav mesh settings for different size creatures. If you had like a gigantic creature that you want to, when we worked on Avatar Frontiers of Pandora, we had actually 3 different sizes of nav mesh for 3 different types of characters based on their size. We had the small nav mesh layer for like the little small viper wolves. We had the human one for humans, and then we had these big amps, the big kind of robot mech suits, and they needed their own large layer. But then for the biggest wildlife, which are like the size of like elephants or woolly mammoths, we had like the humongous, nav mesh layer. So you would actually sometimes create multiple different types, because each nav mesh is going to be chopped up in different ways based on these specifications. So if you were trying to have the giant woolly mammoth character navigating on the small nav mesh that's used for the little viper wolves, then that wouldn't work at all. So you can see that you can actually adjust things like what's the maximum slope that it'll try to traverse upward. Like the height of the agent would have to do with like the clearance that you're seeing on like the things that you have overhanging. Step height can be adjusted to have it be able to step up larger. In a bit, we'll actually put some stairs in there. And so there's also a tab for different ways to mark up different areas, which is much more advanced. But what I like to do is just kind of take that navigation pane and put it behind my inspector so I can access it if I need to. So let's take this a step further. And let's say that we have a really big level. Let's take our ground. Actually, rather than take our ground, let's create some more ground by taking another cube, naming it like more ground, and then making it, for example, still like 1 unit high, but I don't know, you can make it like 30 by 50, for example. I didn't press the 0 for some reason. 30 by 50. So now I've got this other piece of geometry. If I reset it so that, oh, whoops, I need to reset just its position. So if I go 0, 0, 0, and kind of put it here and here, let's say that I'm building out my level and like, oh, I had originally had, this nav mesh here, and then I put some more ground over here. You might think that, oh, well, now I need to add a nav mesh surface to this new ground, but actually you don't. If you take your original ground and you just you rebake the nav mesh, it'll automatically detect that it touches this other ground and extend the nav mesh onto it. In fact, sometimes it does this to the degree that it's not getting it to go onto additional surfaces that you need to deal with. It's actually preventing it. Like if you have a huge level with all kinds of stuff and you put nav mesh on one cube in the middle, it'll by default put that nav mesh everywhere. So for example, if I, duplicated this ground, I could even like scale it up a bit. I wonder how much I can do that. So if I go back to my ground and bake it again, it puts it on that as well, although it has separated these two. So without fixing this up or creating a link between these two surfaces, they wouldn't be able to. This is essentially what we call a nav mesh island at this point. You can move from this ground to this ground because you can see that the nav mesh there is continuous. But you can't move from here to here because you can see that the nav mesh isn't connected. If I wanted it to, then I could bring it down a little bit more and then rebake the ground. And when I see that they have connected, so then if I wanted to validate this, I could put my destination over here and maybe put my MPC a little closer so I don't have to wait so long to see whether this worked or not. But let's run this and see. So hopefully my little guy, yep, is going to move and cross over here onto this other ground. So in other words, you only need the nav mesh surface component on one piece of ground, and any other pieces that touch it, will actually get the nav mesh when you bake it. It automatically detects that. And like I said, that can be nice, but sometimes you don't want that. You actually, are like, this thing that it's building nav mesh on is a building. I don't want them to walk from here to here. How do I tell it not to bake nav mesh here on this thing? And there's a couple ways to do that. So one thing we can do is if we go back to our nav mesh surface, in the nav mesh surface component, there's a use geometry field that you can set to, or no, it's not use geometry, it's collect objects. Under object collection, collect objects. Currently, it will take every game object that's attached to this. I wonder even if it has to be attached. Let's see. If I were to actually move this so that they're not even attached and then bake it, it still puts nav mesh over here on this thing, even though they're not touching. And that's because collect objects, it says put it on all game objects. If I change that, I see that there's also, I can choose volume, I can choose current object hierarchy, or I can say nav mesh modifier component only. So if I say current object hierarchy, that's going to mean this ground and any children. So if I rebake it now, it's only on this ground. And I'm like, well, what if I want it on this one, but not on this one? Well, then what I would do is I would take this one and make it a child. So now this piece is in the object hierarchy. And so if I bake it, it gets the nav mesh too. So controlling where nav mesh goes is going to save you a lot of headache. And especially if you take a really complex level that somebody's given you, or that you, for example, I have some asset packs that have really crazy complex levels, and if I just try to throw nav mesh down on them, it goes everywhere, and it's like, no, like I can't I can't even grok that. I mean, you can also use a volume, and you see when you do, it gives you a volume to start with, and this can be edited just like if we put a box collider on something and we edit it and you drag it out, so you see now I could actually make the nav mesh be only on a portion of this object. When I bake it, it's only within that volume that I've specified from within the nav mesh surface component. So that's another way to get more precise about exactly where the nav mesh goes, which can be super useful. The other setting for nav mesh modifier component only will refer to those nav mesh modifier components that, for example, we put on the MPC, let's see, so that it wouldn't, let's see, did I not do that on, yeah. So for example, the destination has a nav mesh modifier component. That's how we got it to be ignored when the nav mesh baking was happening, because we set it to remove object. But that's how you can also do add or modify. If you wanted, let's say like, oh, if I put a nav mesh modifier component on this and say add or modify, and then I go back to my ground and I switch this back to all game objects, bake it, then I think that should have done. Let's see. Forget. I may have just talked myself into a corner. So now you've seen how to control where nav mesh goes. Nav mesh will automatically cut out objects that you place on the nav mesh grid, and that you need to rebake them. Another fun thing that you can do too is, actually, let's have you do this right now, just because it's a hoot. But so you've got you've got one NPC who's navigating to, your destination. Well, what about more NPCs? Let's go ahead. You can hit Control D to duplicate a game object. So if you select a game object and hit Control D, give yourself a bunch of NPCs. And spread them out. Just think of this as like a what if. Let's see, I think I've wound up putting some of these way below the, let's see. So yeah, you definitely want your NPCs to be on the nav mesh. So when you duplicate, you want to make sure that you're spacing it out using just the XZ plane. But after you've got yourself a mess of NPCs, go ahead and hit play. And note how they all independently, will move towards, their destination. They'll clump up and they'll push up against each other, and it may be a little awkward at times. But the point is, you can actually write a script. For example, we last night at the introductory class, we wrote a spawning script that would spawn game objects based on giving it a prefab. So you can spawn NPCs and you can destroy NPCs, and you can have them follow the destination around. They're not using any kind of special flocking algorithm that keeps them a certain distance from each other, but you can by moving the destination around, you can see how they create like a lumpy formation. And so, eventually, the limit to the number of NPCs that you can have running in this manner really comes down to what your computer can handle. But it's actually, fairly lightweight. You could try to create a, Vampire Survivors type game where you have just oodles and oodles and oodles of NPCs, and just see how far you can push it. There's some famous mods for some various games where they just tried to say what would happen if I had 10,000 crocodiles fighting like 10,000, woolly mammoths. And so, that's something to know that like you can play around with it as well. So then, let's see, there's some other things that, so we're just having something move, directly to a predefined point. But let's say that we wanted to create like, an RTS game or something like that, where you select an NPC that's on your team, and then you tell it to move to a specific point that you click. So, that's an example of something that, I actually asked ChatGPT to write for me. And so I called it Click to Move. And it's not terribly complicated. You're doing essentially the same thing. You need a NavMesh agent. You put this on a NavMesh agent, and get its NavMesh agent component. And then, you just basically need to, have the camera so that you can know where you click and translate that click into a location on the NavMesh. So rather than have you write this, as I'm going to post it into the Discord, and so you can just kind of take it and copy it. So first, you want to create a script that is called Click to Move, because the name of the script has to be the same as the name of the class that's written in the script. But provided that you have that, copy this code in there. And, this is a relatively common thing that you might want to do. So I thought that it might be fun for you to have access to a script that will do this for you. And as I mentioned, like, it's pretty easy to have ChatGPT write this for you. And then even better is to have ChatGPT explain to you what's going on here and why it works. So you see, for one thing, is we're using the new input system that is part of Unity 6 by default. And so essentially, like, if we take this Click to Move, let me see, I think I have a scene with. I think that what I did was put it onto the camera itself. Let me see. I'm going to go to my test scene, and I'm going to take that script, Click to Move, and I'm going to put it on my my main camera. And I think I can just take the camera and drop it in there. Let's see if this actually works. Oh, first thing I'll have to do, I'll have to either disable or remove the move to point script that's on the NPC, or else those two things would conflict. I might also want my camera to be more up above the scene looking down. So let's see if we can get this thing to work. So actually, like, I wouldn't need this destination at all, because the destination will now be the place that I click. Okay, there's no NavMesh agent attached. Ah, gotcha. So this is intending to go not on the camera. I don't even remember the script that I had. This thing, I need to put this on the NPC, and I need to put the camera in here. So now let's try that. So, So now my NPC will go to wherever I click, because what's happening is my click is being translated from the 2D space of the camera view to the location in this 3D world. And that's being set as the destination for agent.setDestination. So is it working for y'all?
Oh, I'm actually.
Oh, it's going fast?
No, I meant.
Oh, my explanation. Oh, my bad. I'm shooting from the hip with these classes. I'm a little less practiced. So yeah, what you want to do is you want to create that click to move script. And then you want to paste the code that I put into the Discord in intermediate general. And so you should get this. And then once you've saved it, next thing you want to do is when you go back into Unity, you want to place that script onto your NPC. And so you can either disable move to point or remove it entirely. Either one works. Then you drag click to move onto here. Don't need it twice, Brian. And so when it comes in, it needs to know, it needs this main camera property. And so what you do is you drag the main camera from the hierarchy onto here. And that's because it uses the camera to get the position in the 3D world based on how you're clicking. So when you have that, and again, mention that you may need to adjust your camera to have it more like a kind of omnipotent looking down kind of position. So if the majority of your grid is visible, then it'll be the case that you can click pretty much anywhere on the nav mesh and have it go to that point. And because your script knows, obviously, you know, when you click on the screen, it knows where in this 3D space the destination is. It means you could also do something like spawn a particle effect there so the player gets feedback. If I click here, maybe I want there to be a pulse, and then it moves to that location. So that player gets the feedback that they clicked in that spot and you know where the destination is. Okay, so let's see. You have move to point. Let's see. You have two move to point scripts.
Oh.
So you want the click to move script.
That
That's I like that fix. That's an easy fix. I know following along with this, especially the first time you're doing it, can be challenging. You know, I've done this dozens of times. This is probably one of my favorite things to do at a game jam, which is like, ooh, do we want NPCs to move on nav mesh? Because I know how to do that. That's pretty easy. And it's a fun thing to do. People think that it's really super complicated. So like, ooh, wow, you're an AI programmer, huh? Like, I know a couple things. Yeah. So does it work for you now?
Oh, yeah.
Excellent. Is it working for you, Felix?
Yes.
Excellent. All right. Well, I have a few more tricks to show you then. But the nice thing is that now that you've written these scripts, this click to move script, this move to point script, you don't have to write them again. If you want to, you know, there's ways that you can export things from Unity as a package and open them up in another Unity project, but you don't even have to do that. You can actually, for example, this move to click to move script, if I right click on it and click show in Explorer, here's the .cs file. I can literally just like drag and drop that into another Unity project and boom, like I have the script there. I just hook things up and I've got all the functionality. So the whole point is that you should start to build up your own library of tools. And once you've created a tool and you have it working a nice way, then there's no point in doing it all over again. You can just bring that in. So one of the other things that I wanted to show you, let's see, is the idea that, so what we've done so far is we've worked with, for example, if I go back to here to my test project, if if I'm running the game, let's say that I've got this wall, but if I move this wall, the nav mesh doesn't get updated and it just passes through that. Like, what if I want a dynamic obstacle? What if I want a train that's going to come through here? What if I want something else? What if I want a dynamic way of cutting out the nav mesh and having the MPC respect a moving object? And it's not actually that difficult to do this. So if we select our wall in this scene, and we add the nav mesh modifier component. Is it? No, it's nav mesh obstacle, my bad. If we add nav mesh obstacle, and we click the box for carve, and then we go back to our ground, and we bake again, you'll see that like it still shows that the nav mesh is cut out, but now if I start the game running and I select my wall, as I move my wall, you'll see in the debug that it's actively carving out the nav mesh as I move it, and that I can mess around with my MPC here, and he continues to try to avoid the wall. So I've created, just by using this nav mesh obstacle on my wall, it's important that you check the carve checkbox. Now I can animate that object in order to have it cut out the nav mesh and move around it. You could do this, you could have an MPC moving on the nav mesh that's cutting out nav mesh for some other MPC as it's moving. So, relatively simple way to create dynamic nav mesh cutting. And you can even see it without running the game, that when I've got this wall, I've got nav mesh obstacle with carve on it, as I move it around, the debug view is updating to show that it's cutting out that nav mesh. And let's see, you have these, you can even adjust the size. So if I say, okay, I don't want to change the size of the object, but I want to change the amount of nav mesh that's being carved out to give a little bit more buffer around this thing. And you can see that, you can actually visually see that that's happening. And of course, when you run the game, the nav mesh agent respects that, because all it cares about is the nav mesh itself. You can see it does take a moment to update. And I think I just went vertical. But there, now you have the tools to create a dynamic nav mesh cut. Of course, you don't want to overdo that. If you're like, oh, this is a lazy way that I don't have to rebake things every time. Like, there's a reason why people bake it, because if you try to do that with a really complex scene and a lot of things that are dynamically cutting out the nav mesh, you're going to get poor performance for one, and like the result is not going to be as good. So you want to use it with care and caution. All right. So the next thing we're going to look at is, what if we have a situation like this, where what if we want to have like a shooter game where you've got like a Unreal Tournament style level where you've got multiple, like a floor with a connection. And it pretty much does this out of the box. Like if I go back to my test scene. Now, this is one of those cases where actually it's a great opportunity to use ProBuilder. Not only because we want a wedge for this example, but because we're going to do an example with stairs. So chances are in your package manager you already have, I know that in package manager you already have ProBuilder. So I think actually, you don't want that one. You want to go to the Unity registry, and you go to, if you type ProBuilder here, this is the one you want. So if you add bring in the ProBuilder package, that'll give us access to more complex 3D objects and a stupid simple way of making stairs. So go ahead and add ProBuilder. It might take a second to to compile. There might be dependencies. But this is a great opportunity to practice using ProBuilder. And so, yeah, let's actually, so when it's in, ProBuilder shows up under Tools. You got Tools, ProBuilder, and there's all, it's got a lot of things here. It also adds it so you could just right-click in the hierarchy and go down to ProBuilder. So if you were to do, I'm in my test scene, I'm going to do, go down to ProBuilder, and let's go straight to creating some stairs. So by default, I've got this staircase here. And I can adjust, I can get it to roughly where I want it. And I can adjust the number of steps to be, roughly what I want. And for example, I want to make it longer or wider or taller. You can do all that procedurally. So get yourself a set of stairs that are, sitting on the, roughly on the ground. If you're in isometric view and you're looking down like the Z-axis, for example, that can be helpful. So before we do anything, if we just go ahead and click the ground and click bake, you'll see that by default, provided you haven't made the step height or the ramp too extreme, the nav mesh is automatically going to cut out from the base, but also give a route up the stairs. And so now let's take that a step further, and let's create a 3D object, a cube, that we're going to use for our second level. I could name it second level if I want, and I can kind of position it and scale it roughly to the dimensions that I'm looking for. And I look at it from the side, move it into position. Now, one of the things I want to do is I want to actually make sure that, in this case, I want to have it almost be like a house with multiple levels. And so I want my my agent to be able to go underneath it. It used to be that was a really difficult thing to do and quite complicated, but not so much anymore. So what you want to do is all right, make sure that your stairs and your second level are high enough that your cube would, or it's not a cylinder, it's a capsule. Your capsule will be able to go underneath it. So in my case, I need to make my stairs higher, bring them up a bit. So it'll take a little time to massage this. We're not in any big rush. So you're essentially trying to just make it so that, okay, I know that I can get my MPC underneath this, because I'm trying to create kind of a I'm trying to see, can I use navigation mesh to create a multi-level surface where you can walk both underneath it and on the level above it. So then when I go to my ground and I hit bake, I'll be able to see, okay, yeah, actually, like the debug view of the navigation shows that I should be able to navigate both underneath the second floor as well as go up the stairs and onto the second floor. But then the real proof comes when we press play and have it move to the destination. So I'm going to go ahead and put my destination up here on top. I look at it like this, and you see how I'm moving. I'm in an isometric view, and I kind of jump from like a side view to the top view. Top view I get centered in the top view. From the side, I make sure it's the right height. Kind of pivot around it. Yeah, that looks about right. So now, all right, now's the moment of truth. Will my MPC capsule navigate up the stairs onto the second level if I start them underneath that level? I don't know. I'm nervous. Let's see. Will it work? Oh, yep. He's moving to the front of the stairs. He goes up the stairs and to the destination. So yes, this was something that used to be incredibly difficult to do, to create multi-level nav mesh that they respected, because at first, MPCs would only look in the single Y value. They essentially translate everything to being flat. But now you can create multiple levels. You could have like a building that you traverse up multiple sets of stairs to get all the way to the top. And of course, because we're using our move to point script, I can take this destination, and he continues to follow the destination. I can put it down on the ground, and he'll go down the stairs to get to the destination. Super cool. Excellent. So yeah, if your second level, there is a clearance by which it won't create the nav mesh underneath it.
Yeah.
So
I adjusted this.
Yep.
To get that.
Yep. Or you could have raised it up.
Yep.
So either way would work. But yeah, usually your level art will dictate, that'll be the fixed constraint, and then you'll have to adjust your nav mesh in order to make it work. So before class is over, I'm going to give you one more thing. So we talked about, all right, now I have an NPC that can that can follow me. If I have a companion character, I could have an NPC companion character follow me. If I want to have NPC enemies that come and attack me, I can use this. But what if I want NPCs that run away from me or run away from something? So the last thing I'm going to give you as far as scripts is a very simple flee behavior. So you would create a script, create a mono behavior script and name it flee behavior, FLEE, capital B. And I'm going to, this isn't that much more complicated really at all. And again, I got help from ChatGPT to do this. All you really have to do is essentially do the same computation as having it move towards something, but invert that to have it move away from something. So I will copy this and paste it into the chat. And so you should paste this into your own flee behavior script and save it. But you'll notice there's actually some parameters that you can fine tune, like the flee distance and the safe distance. And you can look through here, and if you ever wanted a better understanding of this script, you could literally copy and paste it into ChatGPT and say, ChatGPT, please explain to me, what each part of this is doing. Make sure you say please, because when the robot revolution comes, there's always the chance that maybe those of us who are nice to it will be the last ones to be murdered. So, I've got a example here that hopefully still works so what I've done is I've taken my NPC and, I've disabled the click to move and the move to point, and I put this flee behavior script on it. I made I turned the destination into something called threat instead. And so, rather than a destination, we now have a threat. Rather, the destination was something you wanted to move towards. The threat is something you want to move away from. So yeah, when you have your script, your flee behavior script, you put it onto your MPC, and then you'll want to take, what was the destination, which is now the threat. It's the same thing. It's a transform. That's just a point in 3D space that it's going to try to get away from. Give it a flee distance of 10, safe distance of 15, whatever. But now it should be the case that when you run, if you've put your NPC close to your threat, that your NPC will navigate as far as it needs to get to that safe distance. If I increase the safe distance, I think that must have been something that was cached at the start because I can't dynamically change it. But what I could do is I can take my threat and I can move it closer. I'm chasing you. You better run away from me. One thing that it doesn't handle terribly well is getting to a dead end like this and navigating around that. So you can see this script could be a lot more robust and a lot better. But if you're just navigating on a straightaway, like if I just remove these and rebake the nav mesh, having your NPC run away from the threat, pretty straightforward. I can kind of corral it, chase it. So now if you have, like, for example, the player is trying to, like kill or capture or play a game of tag with, this NPC. Now you have the opposite of moving towards something. You've managed to get something to flee from you. And so that's essentially the basics of AI navigation. But I invite you to kind of stress test it. Like, give it the more you kind of try to dabble around with this thing, see where its limitations are. As I mentioned, all of these properties that are in the NavMesh agent are things you can play around with. And then also just think of the applications. Like, what in the game that I would like to make, if I was using something like AI navigation, like what would I want it to do? And am I able to do that with my understanding of AI navigation in Unity as it stands? So figure out a way to try it, make your own little test game.